All right, welcome to part 3 of the Dividing Fractions in 6th grade series. And really, this could be beyond 6th grade and 7th grade and 8th grade. Students are dividing with fractions within other contexts. And this is one of the areas that students do tend to struggle a lot. Oftentimes, there's just a rule that's memorized, but that rule gets mixed up, and we have to try to remember that rule or place which rule goes where. And so, building some reasoning around division and division of fractions will really pay off if we start this thinking in 6th grade and continue to build that up. And so, again, part 3 of the 3-part series where we divide fractions by thinking quotatively. And this is the video where we're going to look at quotients that are less than 1. So if you haven't seen part 1 or 2, part 1 we looked at dividing fractions where we actually have whole number quotients, and then in part 2 we looked at dividing fractions with mixed number quotients, and then in part 3 now we're looking at quotients that are less than 1. And that sequence is very intentional, not just for the video or for the videos, but I also think for instruction to teach division of fractions using this strategy, that sequence, and being intentional of which fractions, which expressions we give our students and when is very important. And so this is sort of the culminating piece where we are now going to look at dividing fractions where our quotients are less than 1. So we'll start with 1/2 divided by 3/4. We're still thinking quotatively, so we're still asking the question, how many 3/4 are in 1/2? How many 3/4 are in 1/2? And students that have a really good understanding of fractional size, when they ask this question, they might think, oh, there's none. And there aren't any whole amounts, right? So that's the first kind of clue that students can see is, oh, this is going to be a quotient less than 1. Now that doesn't mean that we're going to think about it differently, doesn't mean we're going to draw or represent it, model it any differently, but we do know that our quotient is going to be less than 1. So if we wind up with a quotient greater than 1, that's a great opportunity to sort of assess reasonableness and know that we might need to back up and check for an error. So quotient's definitely going to be less than 1 because there's not 3/4 is bigger than a half. But we're going to figure out just how much of a 3/4 is in 1/2. So we'll start with 1/2. And actually, instead of 1/2, just like we did in the last video, where we started to realize that, it's a little easier if I think about these as having the same denominator, makes the visual work a little better. I'm going to go ahead and think about 1/2 as 2/4 instead of 1/2, that equivalent fraction. So how many 3/4 are in 2/4? So there's my 2/4. Now I'm going to show 3/4. I made sure that all of those partitions were nice and lined up. How many 3/4 are in 2/4? And now with the visual again, I can see that it's 0 in something. There's not a whole amount. So now we have to kind of think, right? If this would be 1, right? If I overlaid the 3/4 on top, if this would be 1, now we're just thinking, well, what is this fraction? What did I need and what do I have? My numerator is going to be 2 because I have 2 parts. And my denominator is going to be 3 because I needed 3 to have a whole piece when we were asking that question. So if we kind of look here and rethink, all right, so here's what would have been my whole, and ignore this here, we can kind of clearly see that we have 2/3 of what we needed. So there's 2/3 of a 3/4 in 1/2. So 1/2 divided by 3/4 is 2/3. And I'm going to go ahead and redraw that back up there so we don't forget that it did start as 2/4. All right, so one more, another example here, 2/3 divided by 5/6. I'm going to go ahead and think of this as having a common denominator. I'm going to find an equivalent expression for 2/3 that has a denominator of 6. So my question is, how many 5/6 are in 4/6? So I'm going to draw 4/6. I'll start with thirds and then cut each of those thirds in half. So 4/6 is what we're starting with. And I want to know how many 5/6 are in that. Make sure my partitions all line up. How many 5/6, how many of this green are in the blue? And so here's where 5/6 is. I want to know how much of that do I have? And I have 4 of the pieces, but I needed 5 of them. And so 2/3 divided by 5/6 is 4/5. And maybe by now you've started to notice a little bit of a pattern. And as we've been redrawing these models to have common denominators, to make the models look a little better, to make the models more friendly for finding how many of those fractions are inside of the other fractions, and then we've been rewriting our expressions to have common denominators, you may have noticed a pattern by now. And so when I think of 2/4 divided by 3/4, I have these common denominators. My quotient, 2/3, is actually just the numerators from my expression rewritten with common denominators. And 4/6 divided by 5/6, I had those common denominators, was just 4/5. And this is something that I wouldn't want to teach as a rule, saying that find a common denominator and then it's the first numerator over the second numerator. But this is something that students might start to see, patterns that they can see, that they could test as they're making those generalizations. And as we draw more and more and represent more and more of these, there's a pattern that's sort of going to occur, especially, and it's very visible when our quotients are less than 1. As I was redrawing that fraction on top of the other bar, we're just sort of thinking, okay, well, I need 5 pieces to make a whole. And that 5 pieces is represented by this numerator. But how many pieces did I have? Well, I only had 4 pieces. And that is represented by this numerator. So when we have common denominators, we might actually be able to think quotatively even without drawing the model. And so if I were to think 7/8 divided by 2/3, how many 2/3 are in 7/8? Well, I'm going to go ahead and rewrite this to have common denominators so that it's a little more friendly to think about when I ask that quotative question. I'm going to use a denominator of 24. That's something very common that students will do, is just multiply the denominators together, and sometimes that's okay. Sometimes it works out to be our lowest common denominator, sometimes it doesn't, but we don't always have to have that. If we do, and if it works out, then it does, and that's okay. So I need a fraction that's equivalent to 7/8 with a denominator of 24, and so that's going to be 21/24 divided by 16/24. So my quotative question now is how many 16/24 are in 21/24? And if both of those bars were broken into the same number of pieces, really what we're saying is how many 16s are in 21. And well, how many pieces do I need? I need 16 pieces. And how many pieces do I have? I have 21 pieces. And so that fraction is just going to be 21 over 16. And so we can start to think about that quotatively even without drawing the bar model once we've built that understanding. And so I wanted to show that that thinking can happen even when we aren't dealing with quotients less than 1. So when we have quotients that are less than 1, quotients that are mixed numbers that are greater than 1, quotients that are whole numbers, sort of that way of thinking, dividing fractions using common denominators is a great strategy that not only gets us the right quotient, but allows us to build reasoning on the way there.